Hey, this is Workbench from Workbench Quagmire, back again with our free code camp 100 days of Python certification. Free code camp Python certification in 100-ish days. That's better. Today we are going to go over, pardon me while I situate some things. We're going to go over the code for the build a hash table certification project. You can see it's not a lot of code here, so we'll kind of walk through that a little bit, show you that, and then we'll move on to bigger and better things. Also, down in the corner here, hopefully you can see that we've got a bit of a printer stream going on at the same time. Let's see if I can make this bigger. Yeah, I don't think it takes. There we go. All right. So I'm printing right now, and that's actually streaming live on YouTube and Rumble and Twitch. So I don't know that I have all my info in my description, so I probably need to do that. So anyway, let's just read through this and what the requirements are and talk about how each of these is satisfied. You can see I've got some tests in here already. In this lab, you will build a hash table from scratch. A hash table is a data structure that stores key value pairs, so basically like a Python dictionary. A hash table works by taking the key as an input and then hashing this key according to a specific hashing function. We use a very, very simple hashing function, I think, on this one. I doubt this is how this really works within Python. So, for purposes of this lab, the hashing function would be simple. There it is. It will sum the Unicode values of each character in the key. The hash value will then be used as the actual key to store the associated value. The same hash value would also be used to retrieve and delete the value associated with the key. Objective: fulfill the user stories below and get all the tests to pass to complete the lab. So the first user story is, should define a class name hash table. I've got a class name hash table with a collection attribute initialized to an empty dictionary. When a new instance of hash table is created, the collection dictionary should store key value pairs based on the hashed value of the key. So this is a little bit redundant. We're using basically Python's version of a hash table to create a hash table, but here you see we got our collection attribute. That is an instance attribute. So the hash table class should have 4 instance methods: hash, add, remove, and lookup. So we have hash, add, remove, and lookup. You'll notice we use hash, hash, hash in every one of them, so it's at the top here. Hash method should take the hash method should take a string as a parameter. So here we have key. Return a hash value computed as the sum of the Unicode ASCII value of each character in the string. You can use the ORD function for this computation. So I had to actually Google this. But basically it gives us the character for each character in the key, and then it uses the sum function to sum them and returns that value. The add method should take 2 arguments representing a key value pair and compute the hash of the key. Use the computed hash value as a key to store a dictionary containing the key value pair inside the collection. So add, we get the key, we get the value. The hash value is the hash of the key. Basically, if hash value is not in the collection, then we say collection hash value, and then create an empty dictionary. And then basically if it's not, if it is in the collection, then we basically say, hey, we want to go to the hash value, the key for that hash value, and change the value. Or in this case, add the value. So yeah, so use the hash function compute. If multiple keys produce the same hash value, their key value pairs should be stored in the existing nested dictionary under the same hash value. you can see an example. So we add dear friend and read book. So dear and read have the same characters in it, so they're going to have the same hash, which is 412. And so then we just end up adding read book to dear read, or vice versa. Can't remember how my tests work, but basically we just add to that existing dictionary. Remove should take a key as its argument and compute its hash. Confirm if the key exists in the collection. Remove the corresponding key value pair from the hash table. If the key does not exist in the collection, it should not raise an error or remove anything. So again, the very first thing we do is we hash the key, and we say if that hash value is in the collection and the key is in collection hash value, then we delete the collection hash value key, which would delete that key value pair. Otherwise, nothing happens. It just carries on. Nothing's returned. Just moves on. That, I think that if you look at the... where you're going to have problems is on this test 10, I believe. This is where should not raise an error. I had a lot of problems with that. And if you go look at, our little help friend here, everybody else has problems with it too. And it's about being very specific about removing this key, checking for that key in this hash value. So if you do this check correctly and check both of the hash value is in there and the key is in there, and then you delete the right thing, which is the key value pair associated with that particular key, and then you're fine. It doesn't give you a lot of information. Like when it's failing, it's not telling you why it's failing. Like it doesn't give you very good information. So I'll just tell you right now that you're going to have problems with that. I did. So, and then our last function is the lookup method. It takes a key as its argument again, and then we hash the key. Compute the hash of the key and return the corresponding value stored inside the hash table. If the key does not exist in the collection, it should return none. So again here, if the hash value is in the collection and the key is in the hash values or collection hash value, then it returns that dictionary for that hash value key. Otherwise, it returns none. So that's it. Here's just some of the things I did, and it basically I copied these tests that it was doing to make sure I was getting the right things. I had issues with the hash, and I'll show you what happens, because this is just word of warning. It's the selfs. If you've watched enough of my videos, it's the selfs that get me. So if you go in here, I think if you just put hash, yeah, look at this. All your hashes go insane because it's not using the instance. I have no idea what's going on there. It's probably some sort of deep memory error kind of thing, but watch out for that. I had that problem. I always forget my selfs. You know me. I don't think about self. So those are sort of the things that you're going to run into, the things you're going to see as you work on this project. And that's that. So up next, let's see. We go into our algorithm section. So we just have two theory sections here. And I think I've on my main account. So just so you know, with my Workbench account, this is not my regular account. I have an account. I'm a supporter. So when you get the little supporting things, I don't get them on my main account. I cut them out here. But I think I'm up somewhere in here. So next time we'll do these two theory sections, and then we'll do the implement binary search algorithm, which I actually created my own binary search as I read through this because they give you a good example. Implement a bisect method, which is basically the same thing. Implement a merge sort. So we just have 1, 2, 3, 4, 5, 6 of these lab workshop type things after we do these theory sections. So it's just going to be a lot of labs and workshops. I tend to do them ahead of time because I found if I don't, I end up getting hung up and I have to really edit the videos down. A 40-minute video, I cut like 15 minutes out of it where I'm Googling about the problem I'm having. So we got that. We got our certification project, which mathematical puzzle, Tower of Hanoi. Might want to do some research on this one because I've heard of that. I don't know what it is. Looks like a bunch of lists. So we'll do that. Then we're down to, we're getting there. Dynamic program is really short. So you have like one little theory section and then calculate Fibonacci number calculator. If you go on to, there's a well-known kind of coding puzzle type thing, and I can't, Project Euler. Project Euler, it's like EULER. If you go on there, I think the Fibonacci number calculator is the very first test they give you to solve. It does it in a weird way. They don't care what your programming language is. You basically write an algorithm to solve it, and then you feed it, some input, and then it says what's the output, and it matches those things. So that's just one lab there. One theory, one lab review, and we don't go over the reviews and quizzes, and then Python review, and then the certification exam. So it'll be interesting to see how that works. Actually, let's click on it and see how it works. You need to accept the academic policies. Probably says you can't Google about it, but people will anyway. No attempts, exam token. Open exam environment, download the latest version, manually download the app. Okay, this is pretty in-depth. So probably want to do a little studying because I'm guessing, whereas these reviews we've been doing up till now, like this quiz, you can just fail them. Tells you what's wrong. It doesn't tell you the right answer. It tells you when you got wrong. You can just retake it again. I had to do that with one of them. So anyway, next time we will hit these theory sections and carry on through these workshops and labs. So thanks for watching the video. Don't forget to comment, like, and subscribe, and see you next time for the start of our algorithm section.